identical to the right, so that if you have a bilateral patient, you can be guaranteed you can have an exact duplicate of the left and right prosthesis when you finish. The first thing to do is determine the patient's ankle circumference. Of course, we're not really concerned about the calf circumference because, as you know, in prosthetics, 9 times out of 10, the calves are too large in the first place. Plus, the finishing molds are beveled in the back. See the way they taper down in the back? And the idea of that is so that the mold will flare up into the socket and help create an even, smooth, gradual transition from the socket to the finished cover. Now, this patient happens to be an 8¼ inch ankle. So we selected an 8¼ inch right finishing mold because she's a right BK amputee as well. And the finishing mold gets fitted over the prosthesis. And the most important thing about all this is to view the prosthesis first. Before you go ahead and pour foam material inside the mold, you want to look at the prosthesis and view it for shape. Okay? You're not really concerned with how everything looks just yet, but it should look like a generally normal shape for that particular patient. For example, this is the 8¼ inch mold, which is an average height, average build female. Now, if you go to the 8½, this mold was made off a tall, slender male. If you look at the difference, they're very different in shape. Now, if the patient happens to be 8½, but looks like the shape of the 8¼ you use the 8½ mold, which is longer and more slender, and then thin down around the ankles. The idea is to minimize your shaping time. So that's the reason why the molds change in shape as they change in circumference. It's not always that you're going to use exactly that ankle circumference for that particular patient. We realize that there are many different shapes and sizes of amputees, but if we were to give you a mold for every single shape, no one would purchase them because you need hundreds of them. So we figured out a way to keep it limited to a group of 14. Okay, so we're going to put the 8½ right away, and we're going to use this 8¼ right finishing mold. The first thing we're going to do is, on many prosthetic feet, they have a very sharp proximal edge. Now, the idea is that the foam will now cover the prosthetic foot and hide the transition between the prosthetic foot and the foam cover. We want to turn this into one monolithic unit. So what we're going to do is, the expert technician, Dr. Dean, will come over here and bevel the prosthetic foot so that we can get the finishing mold to fit over it. Now, he's going to take that into the machine room and bevel it. That's the next step. There you go, sir. Now preparing the finishing molds for an EndoFoam project. So what Dean has done is clamped the back of the mold and lined up the grooves. There are posterior grooves on the back of the mold. If you line them up, you'll be guaranteed that the inside of the mold will mate up together, so you don't have any rough edges down the posterior side. So after you put a clamp down on the bottom, then you take some clear 2-inch packing tape. Pull it very firmly over the mold and the prosthetic foot. The idea is that you want to pull the mold down as tightly as possible on the prosthetic foot, which will ultimately create a very smooth skive of the foam into the foot. If you tape it down loosely, you're going to have it kind of rough, and you'll have a lot more finishing to do later. I mean, buffing and polishing. And the idea is to do it as little as possible. Now, what Dean has done is clamped a little higher. And now he's going to take the proximal side of the mold down to this prosthetic socket. Again, pull down firmly. see what you got now. Okay, now what you have is, this mold is taped down to the socket and the prosthetic foot, and what you really want to do is look it over at this point. Now if you see there's a little bit of a bump in here, that's from the socket itself. Now it looks like a problem, which may be, but what we've actually managed to do was fill in with foam around this rise in the prosthetic socket, so it's actually finishing the foam out, and you'll see the foam at the end sky right into the socket around that area. Okay, now what Dean's going to do is fill in the back, and we're ready to pour this material. Let me put a clamp up higher. Okay. Let's see. You know. Now you want to make some kind of tool up so that you can hold the prosthesis down while you're doing this project. You don't want it jumping around while you have all this gloppy, liquidy foam running around. So we made up a little jig there, which you can very easily make in your own facility. Right there is a little wedge that you're going to put into the groove on the finishing mold so that you can hold it open, enabling you to pour the foam in during this process. But one thing you don't want to forget, doctor, is you got to keep a clamp on both ends of that wedge so that you make sure that the mold is not going to shift around on you. Now you have it open, and we're going to mix up, in this case, 200 grams of EndoFoam. This is a product that will allow you to make about 40 BKs off a 1-gallon kit of material. Now follow the instructions. Shake well before every application. The nice thing about this material is that you can adjust the density of the foam by adjusting the mixing ratio. For example, if you wanted the foam softer to match a sedentary little old lady, you would mix it at a ratio of 85-15. And if you wanted it firmer to match more of a muscular person, you can mix it at 70-30. So you have a range of mixing ratios. Also, that also proves that you don't have to be exact with the mixing ratio, as you can see.
You said 200, that's screwing me up.
What do you do, 200?
Yep.
Okay, we're molding, we're going to make a total of 200. So that means, and that's 75-25. So we're doing 150 of the part B, which stands for big, and 25 and 50 grams of the part A. Now once you have that mixed, you want to have your clamps ready, your mixer ready, everything ready to go, because you're going to be mixing this very well and pouring it into the mold as quickly as possible. The material will not begin to foam up until you stop mixing it. So you want to mix it for about 10 seconds or 15 seconds, or until you do not see any more color swirls in the material. Now, at this point, quickly pour it into the mold, and if you can get it all into the mold, it takes plenty of time for it to rise. But the idea is you don't want it to be rising in the cup and have difficulty pouring it into the mold. Now remove the clamp and take some more, the wedge, and take some more of those clamps and clamp the remainder of the finishing mold tight. The idea is that you want to close up this system so that the foam purges out of the system in the weakest area, but you want it to build a little bit of back pressure. Dean, you want to back up so they can see it rising? There you go. And if you allow it to build up a little bit of back pressure, you can minimize the potential for having large air pockets or weak areas in the material. But at this point, you could just about walk away from this project and return in 15 minutes after the EndoFoam has set. And you can see it kind of rising. You zoom in on there. See it now? You're going to see it form right around the socket. There it goes. And you'll see, I think there's an air pocket around the ankle yet, right? You'll see it around the ankle filling in too now. Oh, that's nice. And you'll see it purging out of this area, but it's filled in everywhere else. Now, in some cases, the average BK, you could use a total of 200 grams mixed in any mixing ratio you prefer. We like 75-25. We get the most consistent results and a real nice feel to the foam cover. But if you're doing a larger BK prosthesis or using a foot with a hollow foot shell, like a Seattle Light or a Flex foot with a hollow foot shell, you may want to go to 250 or 300 grams total. But mixing it at 200 grams will do the average standard BK with a standard length residual limb. Also, we happen to be molding this foam over our EndoFlex prosthesis. So it's its own mold release. If we ever have to get to the prosthesis, it will peel away from the copolymer. But if you're molding it over a modular system where you want to protect the componentry underneath or be able to access it in the future, before you do the finishing mold, wrap the componentry with some saran wrap or some type of plastic wrap, and then do your foam project, so that if you have to get to it, you just cut right through it, and the saran wrap will create a barrier between the foam and the componentry inside. Now at this point, we're just going to leave this for about 15 minutes and then demold it. Okay, all right, so now we've waited about 15 minutes, and now Dean's going to take the mold off this prosthesis, leaving us with an EndoFoam cover. And hopefully we'll have very little shaping to do. So first thing, we reverse the whole process. Remove all the clamps, and then cut the tape away. I want to remind you of one thing. A lot of people using flex feet or spring lights or things with very flat, broad pylons. We've had some experience with these, in using these covers, where they create air pockets of foam in front of the pylon. And the reason why is because when pouring the foam into the mold, if you don't pour the foam past the pylon and into the anterior side of the mold, what happens is the foam lands on the pylon and rises from the pylon back and traps air in front of the pylon. So when using a flex foot or something with a large, broad pylon, the G foot, for example, any of those, try to pour the foam past the pylon into the anterior side of the mold so the foam rises up over the pylon, kind of like a cake rising around it. And that will resolve any of your air problems in front of the prosthesis. Now he's got all the tape off of it now, and then what you want to do is carefully separate the back tabs of the mold. I'll take that, sir. Look at that. Okay, so Dean is very carefully now just going to peel that away. The foam will not adhere to the polyethylene. These are low-density polyethylene molds which don't stick to anything. And out we come. Now, at this point, you don't want to be squeezing it because the foam is now releasing some gases, and if you compress it now, the foam will not return to its original shape. So you want to you want to avoid squeezing it or handling it for about 2 or 3 minutes after the foam has been after the mold has been removed. But you can look at it now. At this point, we're ready to deliver this to Mr. Smith or Jones. If you look at this socket, now remember how that socket was protruding in the mold. But what's happened is the foam has actually covered up that rise and tapered in a blend. And the only finishing we're going to have to do is this little bit of trimming in the back and a little bit of skiving around the heel. And this thing, at this point, we can let this woman go home with a foam cover. At this point, we'll just pull a stockinette over it so she can go home with it and it'll have some shape. But for our purposes, since this is an educational manual, we're also going to show you how to do a prosthetic skin. And the next step is to prepare this prosthesis for the skin. Thank you, sir.
Welcome, sir.
See now. So Dean is just blending and tapering in that foam so it makes a nice smooth transition from the foot to the cover. And the back tab, you see that excess material from the back of the mold, that can be trimmed off with a sharp scissor or a scalpel or a razor. Now we're ready to prepare this prosthesis for the skinning process. We like to use the Comfort Products multi-size stockinette, which is a nylon tubular knit. And it's just a little bit heavier than hosiery, but a little finer than nylon, conventional nylon stockinette. It also happens to be very elastic, so you can stretch it over this project. if you notice, this is the skin itself that the foam is made when it was sitting in the finish mold. But in this area, it's a little bit rougher because it's been grinded to give it that finished shape. The idea is to fill all these pinholes or pockets in so that the whole project is nice and smooth. And we find that this multi-size stocking is very good for that. It's heavy enough where it'll, so to speak, hide all the sins, and fine enough where it'll give you a good finish after you paint the skin off. And we blow this down a little bit. Thank you. And now we'll pull that stocking over it nice and tight. And the stocking will be glued to the prosthesis up at the proximal edge of the socket and also around the foot.
I know we turned it inside out to keep the seam.
Oh, you do? Cool. That's a good idea. And Dean also turns the stocking inside out so the seam of the nylon stockinette doesn't show. Also, this is a way to use up some more tape. Yeah. Now, we usually use 2 layers of multi-size. And the 2 layers will hide anything that you have underneath just about. If you have any deep, real deep imperfections that show through at this point, you can also use some latex caulking and squeegee it over those low areas, and then take a paper towel, wet it, and use that to feather in the latex caulking. After you get your latex filling project done, then you go at it with the multi-size stocking. If you have any real bad areas that look like they're not going to heal themselves or repair themselves through this process here. Now, what you want to do is make a very thin mixture of contact cement. You don't want to use it the way we standardly use it in the cup. You want to thin it out so it actually paints right through the 2 layers of stockinette and into the prosthetic foot and the socket. Now, the reason why we glue it down to the socket also is because this skin is going to be trimmed right up to the edge of the socket. And if you just painted the skin directly over it, it won't adhere to the socket very well. So by using the contact cement first, it'll give you a pretty good bond around the edge of the socket. Some people have problems keeping the skins held onto the socket because if they use, for example, if they use sleeves or things like that where they're pulling the sleeve over the socket all the time, it may peel away from the socket. But you can very easily repair that using a cyanoacrylate adhesive. For example, Loctite makes a product called 414, which is a cyanoacrylate adhesive designed for thermoplastics. And all you do is put a little drop of that and squeeze it together, and then it won't come off. In fact, on some of our more active patients, we automatically bond the edge of the skin to the socket with cyanoacrylate before we deliver the prosthesis. Now, if you notice, Dean has also painted the contact cement over the heel. The reason for that is because when we trim off this excess stockinette to expose the toes, we want to make sure that it's very durable over the heel so that when the patient continually dons the prosthesis into a shoe, in and out of a shoe, you're not rubbing the back of that delicate heel. So by having the heel reinforced with the stockinette, it makes the whole project much more durable and it won't peel away from the prosthetic foot. Now we're going to let this wait for about 15-20 minutes for the glue to dry, and we'll be ready to spray the Duraderm skin on it. Very nice. Well, you take a sharp blade, a scalpel, or a brand new single edge razor blade, or anything that's very sharp and accurate, and cut so we can see it around the heel, up over the instep, and remove the excess stockinette. The reason for this is there's so many pretty looking feet on the market, you don't want to cover them with stockinette before you do the skin. So we figured out this is a good place to terminate the hosiery, and then we'll paint the Duraderm skin directly over the prosthetic foot and the nylon. Now, if you want to hide the transition between that stockinette and the prosthetic foot, you can do your multi-size stocking in 2 stages. glue down the first stage, and then the second stage glue up over the first about a 1/4 inch in front, which will help to hide that transition. You can also fill that edge with a little bit of latex caulking as well. But for our purpose, we're just going to paint right over it. Now at this point, to make sure that this doesn't leave, we're going to take and put a little bit of cyanoacrylate right on the edge of that stockinette and work it in. That will definitely bond the edge of the stockinette to the prosthetic foot, and there's no way it'll leave. Because what'll happen is if you don't do that and the contact cement isn't completely dry, when you go to paint the Duraderm skin on, the stockinette can loosen up. The contact cement can be softened by the Duraderm skin. And by putting that little bead of cyanoacrylate adhesive on it, you'll prevent that stockinette from moving at all. Very nice, Doctor. This is Duraderm, a prosthetic skinning system that we found. This puts a real durable, very cosmetic, skin-like finish on a prosthesis. You can paint this over endo or exoskeletal systems. If you do it over an open cell foam, for example, this EndoFoam that we use, you can use the stockinette as a smoothing out process, or as a laminate so that the skin will have more durability. If you're going over a closed cell foam, for example, those expandable pea-like covers or any kind of closed cell foam like polyethylene foam or an exoskeletal system, do not use the multi-size stocking or any kind of stockinette, because when you spray the skin on, it'll create a lot of air pockets and bubbles underneath the skin. This is a really nice product. You can do about 5 BK prostheses off 1 gallon. The material comes clear. You can add whatever pigments you like to it, so you can color match it any way you like. This can be brushed on, it can be dipped, and it also can be sprayed. The way we prefer doing it is with a spray gun and a pressure pot. We should show this here. This is a pressure pot, okay? The idea of a pressure pot is to fill the paint container with pressure so that you're actually pushing the paint through the gun. That's why you don't have a cup at the end of the gun. Siphon feed guns will not work with this material, because what you want to do is paint it when it's very thick or viscous. This way, with one coat, you can apply a lot of material. The more thinner you add to it, the weaker the skin becomes and the more laborious and time-consuming the process becomes. So we have right now, we're thinning this about 1/5 thinner to 4/5 material. And the way we do it here is we have gallons of different colored material, like this is a little bit darker, and this is a little bit lighter, you can see. So the way we do it is we pick the can for the color that we're going to use for that particular patient, put the entire can inside the pressure pot, and then paint away. This system never has to be cleaned. We leave it with paint in the system at all times. As long as no air gets to the system, it'll stay in that configuration indefinitely. So we never have to worry about cleaning. Now, if you were doing a Negroid patient yesterday and you're doing a Caucasian patient today, the amount of material that's in those lines, don't even waste it. Use it as a base coat when you first start painting your next prosthesis. So Dean has this all ready to paint, and as you can see, it's got the multi-size stocking on there, all glued down. The first thing you want to do is blow everything off. Make sure you have no dust particles on the project at all. If you have any dust, it'll turn into a pimple when you paint the skin up. Make sure you blow it off first. And now, what Dean is going to do is he's going to apply the first coat. The first coat is applied very heavy. You want to apply it so heavy that it fills all the pinholes from the stockinette. And you make a smooth skin texture out of the whole thing. So what he's doing is laying it on gradually. If you notice, the spray gun is set in a horizontal pattern so that you can spray vertically and your pattern is horizontal. That helps you to lay an even, smooth coat of material on it. Now, if you notice, he's laying it on very heavy. It'll look thick and it'll look like it's almost ready to run, but that's fine. Once it dries, it'll shrink down. If as long as with your first coat you can seal all the pinholes in the project, the second coat will be done very dry so that you give it more of a skin tone texture. Notice you have to go underneath the foot to get underneath the prosthetic, to get the instep of the prosthetic foot. You always have to make sure that your gun is hitting all those areas. Okay, let it run. Now, we're going to let this dry for about a half hour, and when this first coat dries, you inspect it to make sure that all the pinholes are completely covered and filled. It's going to look like a vinyl dipped life jacket. Very smooth and very slick. So what you want to do is take away that smooth texture by adding a dry coat for your second and final coat. And we're going to apply the dry coat now. And that's done by backing off on the spray gun. If you notice, Dean is about 18 inches from the project, so that the material is kind of drying in the air as it passes onto the prosthesis, and that's what's giving this dry or orange peel type of texture. And that'll help the skin to look more realistic and take the shine away. And that's it. You want to take the gun away so they can see? Now we're going to let this dry about 10 minutes and then finish the proximal edge of the socket by cutting away all the excess and buffing off the prosthesis, which will complete it. After the second coat is dry, you will let that dry for 15-20 minutes, and at this point you want to take a very sharp razor or a scalpel and carefully trim away the excess stockinette from the project. And if you use very sharp blades, it makes it very easy. Just right along the socket and trim away the excess. And then we'll take this into the machine room and buff off that edge. There's a certain technique to be used when buffing so that you reinforce it and kind of melt the stockinette into the thermoplastic socket. So you'll see that momentarily. Now, you want to buff off the edge of that excess using this technique with the wheel spinning that direction. Whoops! This way, as the wheel is spinning, actually now that wheel is spinning counterclockwise, and actually melting the edge of that stockinette into the thermoplastic socket itself. So by using this technique, it will not peel away, and it will give you a very clean finish. And then we just take on a flexible shaft tool, makes it easier for us, and put a Sandaflex wheel on it just to cut away those burrs and finish the prosthetic edge, the socket edge. Now we're finished. Let's show it. Just hold it still there. I'll get this in closer. You can bring it closer to the camera. Alright, now you can get an idea of what it's going to look like finished. Nice clean edges, and the skin is very well bonded to the edges of the prosthetic socket. Also at this point, like we discussed before, you can just coat the edge, the top edge, with a little dab of cyanoacrylate adhesive and then wipe that clean, and that will really hold the edge of the prosthetic skin to the socket, and that'll prevent it from delaminating through use. You can see how it was done from start to finish using EndoFoam and the Duraderm finishing system. You shouldn't have too many questions at this point, but you can get an idea of what kind of quality you can provide to the patient without spending tremendous amounts of time and investment in material cost. A big question we've had is, how do you manage a shuttle lock, since suction is such a popular thing these days? And we found a very easy way to do it. This happens to be a fill-hour shuttle lock that has been installed inside the EndoFlex prosthesis very easily in this conical region. The way we do it is we shallow the button until it's going to be underneath the cover somewhere. Then you smear this whole area and seal it with Vaseline. And then just finish the prosthesis as you would normally. What will happen is the Vaseline will prevent any foam from getting into the shuttle lock housing or componentry, and also act as a permanent lubricant for this mechanical device. And what's nice about it is when you finish the prosthesis, the foam cover and skin will actually bury the shuttle lock into the system, so you don't see it, but you can very easily feel it through the prosthesis, which ends up giving the patient a tremendous advantage because you don't want this button showing. A quick review. Okay. Just a quick review of the materials that we used in this project. This is the first part. This is EndoFoam and the finishing molds. With EndoFoam, you can create a finished foam cover in 15 minutes with a material cost of $5 per application. The finishing molds are available in 7 sizes left and right, which would give you a complete kit of 14 pieces that you can use for probably 90% of your patient population, if not more. In some cases, when you can't get a mold to fit right on a prosthesis, we find it easier to create a custom-made finishing mold and then put the patient's name on it so that we have it reusable for every time we make a new prosthesis for this patient. The finishing molds are very flexible, 3/32 polyethylene, and can be reused just about indefinitely. Okay, the next product is Duraderm. Using this material, you can apply your own attractive, durable skins in 20 minutes at a material cost of approximately $15 per application. The Duraderm comes also kind of thick in the pink can, and you would use the thinner to thin it out approximately 5:1, Duraderm to thinner. And you can also use whatever conventional pigments you prefer to color match it to whatever your patient's color is. What else on Duraderm we wanted to mention? Oh yes, your best results are going to be achieved if you use a pressure pot and spray gun. You also can paint it on or dip the material, but we find that by spraying it with a pressure pot, you're going to get your optimum results and maximum control over the texture of the prosthesis to create the most attractive looking prosthesis. Another product that we've developed at the Ortho Remedy is a product called the NeoCuff. We found that everyone is using neoprene suspensions, test belts, and copies of test belts for above-knee amputees, and we wondered why no one has really developed a real good suspension in neoprene for the BK amputee. So what we did was marry new materials to an old-style, very effective suspension mechanism. This is the NeoCuff. This area in here is a non-elastic laminated material to inside 1/4-inch neoprene. So this helps to create a good suspension over the patella, as the old cuff suspension used to, and still does if it's fitted properly. But we added a few other details to this NeoCuff that make it work even better. Of course, we opened the patella to allow better range of motion. We also opened it posteriorly to allow better range of motion, so that this way this neoprene surface doesn't migrate down and the patient isn't constantly lifting it up when they get up out of a chair. Also, if you notice, there are additional bar tacks here, so that if you want to give it more range of motion, you can cut this out without the material fraying. Also, there's an additional bar tack on the top, so that if you wanted to shorten the whole system, you can do that without the product fraying. Another addition we put on it was these little discs here are Velcro discs that come with an adhesive Velcro material stuck underneath it, so that after you fit it, you pull it down, peel it up, and peel away the adhesive Velcro, and now you have a solid mechanical attachment to the prosthesis, so that the whole NeoCuff doesn't slide around and shift out of place. The NeoCuff is a very inexpensive sundry. It's priced at $29.95 currently. And it comes in a Ziploc bag, so you can take them out and size them, and you may have to put them back in the bag if the size isn't appropriate. They are sized by femoral supracondylar circumference, so that this way you're sure that in this region here you're getting a maximum suspension. Okay, another product that we have developed here at the Ortho Remedy, which we found to have tremendous success in laboratories doing a lot of thermoplastic forming, is a material called Templo Glass. This is a Teflon-coated fiberglass porous weave type material. And the big word is porous. If you notice, when you put plastic in the oven, it will generally seal around the edges and then trap air pockets in between, so that you're constantly opening the oven door, changing your temperature, lifting the material, and getting all those air pockets out. Since this material is porous, if you can see it up there, you can actually see light through it. Since it's porous, what happens is as the plastic heats up in the oven, the air passes right through the material and prevents you from having to lift it up and shake out air pockets. This is going to give you much more uniform heat and much more efficient vacuum forming also, because what it'll do is leave a very, very slight imprint on the back of the material, which actually helps to improve the vacuum forming efficiency. And this material is available by the foot, and it measures 42 inches? 42 inches wide, and it's on a roll by the foot, so you can get it as long as you like. And it's inexpensive, and it'll also last approximately 1 year in an oven if you handle it properly. That means don't overheat, don't be burning your material, because we don't want to be doing that in this industry anyway.
Tom, Mrs. Smith is here. She's ready to pick up her prosthesis.
Did you finish lunch yet?
She sure did.
Oh, good. Okay, it's ready. I hope you've enjoyed this very low-budget film. Our intention when producing it was to give you a live demonstration on how to properly utilize these fine Ortho Remedy products so that you can win, 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 and your patients can too. To place an order, please call 1-800-662-7993, or if you have any other further technical questions, you can reach us at that number as well. Thank you, and good night. Morning, we come apart when we need to.
Okay, I guess that's it.